Modules and mounting side, we do offer our own in-house IBC modules and our own mounting structure. And we also do offer Longi, Jollywood, and Canadian Solar, which is a new product that we brought into our portfolio and the main topic for today. And looking forward to the training. And on the inverter side, we do offer SMA, Fronius, Victron, Goodwe, Attest, also with SunGrow. And then on the storage side, we do have our own local battery, Solar MD. Solar MD is based in Cape Town, and Solar MD are well known for their innovative technology when it comes to the battery side. And then we do have BYD, which is a well-known battery worldwide. I don't think I need to say any more about BYD. So if you are interested in any of our products, please do feel free to drop a chat on our chat box, and somebody will get in contact with you. So our team consists of Helga and Daniel in the managing position. So Daniel is our managing director. Helga is the head of finance and operations. Then on the marketing side, the people responsible for today's training, Zane and Carmen. So thank you guys. And on our supply chain and sales administration, we do have Shemaine, responsible for procurement. We do have Kim, Michaela, and Tanya, who are also responsible that everything runs smoothly. And on the accounting side, we do have Hamu, who's our financial accountant. So on the sales manager side, so if you based in the inlands or Joburg side, we do have Leo, who's the business development manager that side, who goes hand in hand with Jason. They are responsible for the inland side. So if you do have any questions or need assistance, they will be your main person to contact. And on the western or the coastal area side, we do have David, Carl, and Ridar. So if you do have any questions and you are based on the coastal area, please feel free to contact David, Carl, or Ridar. So if you don't know who your sales manager is, please feel free to drop in your email, and then we'll then make sure that your sales manager contacts you and just to introduce himself. On the technical side, we do have Vessel, who is responsible for the technical department in Joburg. So if you do have any technical inquiries or need someone to come to site or you need technical support, Vessel will be your main guy to support you in that regard. And then in Cape Town, we do have myself, Alton, Juanse, and Jama responsible for the technical division this side in the coastal area. So if you do need technical support, again, please feel free to drop in your email and I will get in contact with you or Vessel will get in contact with you. And just so that everybody knows, we do have an online portal training every second week of the month. This is handled by the sales manager. So if you don't know who your sales manager is, just drop in your email and then we'll then we'll then make sure your sales manager gets in contact with you and then we can then organize a training for you. So this happens every second week of the month. And then we do have something new that we recently brought into our online shop. We do now offer or give out our webinar recordings. So past and future recordings will be uploaded onto our website. Zane will then drop in a link, and then everybody, if you need any training in particular, whether Solar MD, SunGrow, or Canadian, you can find it there. And we do have a special for the month of May. So for any order exceeding 500,000 Rand, excluding VAT, we offer free delivery throughout the month of May. So make use of this. I mean, it saves cost for you as an installer. So if you want to have more information on this or understand how this works, what the terms and conditions are, you can just contact your sales manager and then they'll assist you in that regard. And we do also offer 100 free corrugated metal sheeting adapters when you purchase our mounting structure for corrugated roofs. So this is also part of the month sales deal, May sales deal. So make use of it. Getting free corrugated metal sheeting saves you on your cost pricings and makes you. And this is one of the best, if I may say so myself. This is one of the best mounting structure there is, reliable and German made, German certified, as many people will say. So please feel free to then contact your sales manager to understand how to get the 100 corrugated metal sheeting, just to also get more information on this. And then without further ado, I will then just give Vasilia and Michael the chance to then start with the product training for today. So Vasilia, welcome, and yeah, the platform is yours. Looking forward to your training today.
Hi, Alton. Thanks for the introduction. So please allow me, let me share my screen. Um, okay, I think it should be working at this point. Hello, everyone. First of all, I would like to start with an introduction. My name is Vasilis Nikolis, Senior Product Manager for modules for the EMEA region in Canadian Solar. And today I'm very happy to be here to be part of a discussion, I would say. So we have planned 2.5 hours. I have prepared a slide set, quite generic, just to go through different topics around PV modules, how to recognize them, how to handle them, how to use them, and so on. As an introduction, I would like just to start with a picture which is just the big problem that we are facing at the moment. So the world is getting more populated. Energy needs are increasing more and more. The world is evolving. So right now we even start with artificial intelligence. We need data centers. We have cryptocurrency. We have more and more energy needs. And unfortunately, all these needs are covered at the moment by fossil fuels. And this is more or less a typical picture of a power plant, just emitting all these human carbon emissions to the air. And then from this point, there are so many implications from global warming to air pollution, environment, and so on. So it makes sense that we need to look for an alternative energy source. And we don't need to look too far. I mean, we just need to look around us and observe what actually natural resources we have. And actually, sun is the energy source that it's abundant and actually can give us a sustainable form of energy just to use for our energy needs. So the sun can give enough power to sustain a comfortable lifestyle. But in order to actually enable solar energy as part of our energy mix, of course, there are challenges. And there are challenges for governments and grids. For example, they must ensure that, for example, generation production happen in an efficient way and in a balanced way at the same time. And then once we have the infrastructure there, then all of us, the PV professionals, should choose right products, build systems in ways that ensure long and safe operation. And the Canadian Solar's mission is to enable solar into every household, enable solar solutions, meaning modules. We have business about inverters, energy storage. In the end, all the tools that can make this energy transition possible. And all this in order to create a better and cleaner Earth for the future generations. So for today, I've prepared a set of slides touching 4 different topics. I will start with just going through module type, a bit of technologies, just to give a bit of a background and align everyone of what kind of modules they are and how to distinguish them. Then we will start discussing about how to handle PV modules. We'll talk about best practices regarding installation, operation, maintenance, and so on. And then just going through a PV module dataset, we will see, first of all, what information is there, how we can read it, and then how we can use it. And then we will discuss different little topics around the specs of PV modules. Good. So first part, just understanding the different module types, and I thought that this section is important because I guess many of you are in the industry for more than 10 years, and I guess you have realized that PV modules have changed. And actually, this is a graph taken from PV Magazine. Let me use my pointer. Which on the y-axis it gives it shows the module power output, so from 250 up to 700, and then the x-axis is time, so from 2013 to 2024. Also here, depending on the different time here, you can see different PV technologies. So back in the days, you could remember the BASF. They were very simple. It was a very simple technology as we compare it, for example, with the current ones. And then in 2015, we transitioned to PERC, and then PERC became the mainstream technology for almost 7-8 years. Where at this point in 2023, we started transitioning to N-type technologies. Then this is one change that happened. It was the PV technology transitioning from BASF to P-type PERC to N-type TOPCon and heterojunction, as we will see also in the next slide. And then the next change was regarding the wafer size. So we started with small wafers of 156 millimeters width, square ones. And then we started transitioning to bigger ones, to 158, 166, 182, and 210 millimeters. So all these colors are also explained also here. Then each dot gives just an average power of an average module at each year. So back in 2013, with BASF and 156 wafers of full pieces, full square pieces on the modules, we were around 320. And then we slowly, just by developing the BASF technology, we started doing small steps, going to 330, 350, 360. Back then, these changes were something significant, although now, as you will see, all the big development in power and efficiency, that time looks a bit kind of boring. Now, in 2017, we started changing more and more the wafers. So we transitioned to 158, then to 166, and then by making bigger wafers but keeping the same design, for example, 54 cells or 72 cells, we just started making the modules much bigger. So the effect that you can see here is from just making bigger modules. So we started going to 435, and then the first big change came with the 182s, that we started jumping to the 550s. At this point, all these changes somehow stabilized, and the industry was standardized in two main wafer sizes, the 182s and the 210s. And then they started developing together, the 182s. So it was more or less stable at the 550s. And then the 210s, the ones that go to the utility, they were at the 660s watts. And then we started introducing the N-type, that with the same wafer size, so the same module size, we started increasing just the efficiency, and then with the same size, we would be able to just reach higher efficiencies and powers. And now the last step, and we hope the last one, in order to fully balance the industry and standardize it, is the introduction of the rectangular cells, which means that they are based on the 182s, so rectangular wafers of 182s, and rectangular means that the width is the same, 182, but then we have longer lengths. So this means that right now the new modules, they have the same module width, so 1.1 meters, but then we extend a bit the length, and now we are able to reach the 620 watts. We will see also in detail later. This is a bit also our technology roadmap, also to give you also a different view of what I just discussed about the module technologies. So in the past, we were based on the P-type, and PERC was the mainstream technology. And right now, we have already transitioned to N-type. So TOPCon and heterojunction are the two main N-type technologies that are used for the modern mainstream modules. And then looking a bit in the future, the next step will be to combine TOPCon and heterojunction with the back contact architecture, which means that actually all the metal contacts from the front, as you can see them here, are all transferred to the back. So the front surface of the module will have no bus bars, no wires, and then all the current will be going through the rear side. And then even looking longer in the future, we have the tandem cell, which is, let's say, an advanced configuration at this point. We will use a new material, which is called perovskite. We will put it on top of standard silicon cells at that time in order to reach cell efficiencies that are beyond 30%. But this concept is expected, let's say, after 3 to 5 years. Good. I guess this is already a bit heavy, but we will take a step back just to explain a bit the basics. First of all, what do we mean P-type and what we mean N-type? So this is actually the first distinction when we want to understand a module type. If we see a module and then we understand what are the characteristics. The first one is to understand if it's P-type or N-type and what actually means. It means that starting from the silicon, which is the main semiconductor that we use in silicon panels, at this form, it is neutrally charged. So it doesn't have any positive charges or negative charges. And then we can positively charge or negatively charge by using doping. And the doping, to explain it in a few simple words, silicon, let's say it's a crystal with silicon atoms, and then we introduced either gallium atoms or phosphorus atoms. And then for each gallium atom that we introduce to our silicon, we get one electron out. So in this case, for example, with phosphorus, we would have N silicon, so it means we have negative charges. And then with P silicon, we have more positive charges. At this point, we don't have any solar cell. And these two pieces, independently, they don't interact with light so well. But then if we take them and then we create a PN junction, then we can actually absorb light and then create charges out of it. And then we can have two different solar cell types. So the first one is the P-type solar cell. Actually, it means it's simple. The P side of the PN junction is just bigger. That's what it means. Actually, most of the light is absorbed in the P-type silicon. It is splitted together with N silicon, and then it creates the charges. And then on the other hand, N-type solar cell, it actually means that from the PN junction, it's just the end part that it's actually larger in volume and so on. So this is what P-type and N-type means. And of course, P-type and N-type, they have different characteristics from a physics point of view. The next, maybe just looking at the cell architecture, this is a P-type cell, it's a PERC cell, and this is N-type cell. The base is actually the part of the PN junction that it's larger, what we said in the previous slide. And then emitter is called the counterpart of the PN junction, which is smaller. So in this case, P-type silicon is the base, N-type silicon is the emitter, and the opposite, N-type silicon, in this case, is the base, and P-type silicon is the emitter. Then the next thing that we have is the passivation layer that we use between the PN junction. It's just layers that protect the generated current from recombination, from losing it. So actually, including these passivation layers make the solar cell more efficient. And then the final part of the whole structure is just the contacts, how to collect the generated current and extract it to the bus bars and then the junction box and then to the system. So P-type silicon, it was used a lot with PERC. PERC and TOPCon are actually passivation techniques. So what kind of passivation layers and what materials we use in each case, it means it's PERC either TOPCon. This is the difference between PERC and TOPCon. So the past is P-type PERC. The future, the present and the future is N-type TOPCon. The second distinction, it has to do with the cell type and the cell size. We briefly discussed it also in the introduction slide. In the past, we were using full square cells, but then from one point and then we realized that actually by cutting in half and then changing the module design from a full surface with full squares, creating 3 strings, creating half-cut, using half-cut cells and then splitting it into 2 parts, so the upper one and the lower one, is actually better for different reasons. First of all, it's better regarding shading, because if, for example, the lower part is shaded, then the upper part is still working, and then we save some energy, some reduced energy. And then the other main reason that we transitioned to half-cut cells was that we were able to reduce the current per cell. So in the end, reduce the risk for hotspots. These are just examples of the different wafers that have been used over the decade. And as we discussed already, the industry right now has standardized to 2 different wafers, the 182 and the 210. And actually for this one, right now we are just transitioning to a rectangular form, which I think will be the final step in all this series of changes. Yeah, so the 182 millimeters gives the modules that we know with 1.1 meters width, and then the larger wafer are the ones that have the 1.3. So whenever you see a module that has this module width, then you can immediately understand that it's a 182. If you see a module that has a width of 1.3 meters, then it immediately means that wafers of 210 millimeters are used. Now, when we change, of course, the cell size, it means that we have more area to absorb light, and then we can create more current. So the different cell sizes can lead to different currents. Just to give an overview, all the 182 modules, so in our product family naming, it refers to it as top Haiku 6 and top by Haiku 6. And here you can find the 550s and the 580s, like the 6WT. They are all below 15 amps. So these modules that go mostly to the residential roofs and C&I roofs, they are all below 15 amps. Only the larger modules that go to the utility scale projects are above 16 amps. And this was a bit of an issue a few years ago when we released these larger modules. And then we had to work with inverter manufacturers to ensure compatibility, and we have compatibility letters for all these inverters. But for these modules that are to be used for rooftops, the ISC, the short circuit current, is below 15 amps. So this makes it compatible with almost inverters of, let's say, older generation. Now the third distinction, so we talked about the cell technology, so P-type or N-type, and PERC or TOPCon or heterojunction. The second distinction is the 182 or the 210 or half-cut. And then the third distinction, just to complete the picture, is if a module is monofacial, or bifacial, and how they are built when they are monofacial or bifacial. So monofacial means that the module can absorb light only from the front side. This means that the front side has a glass, and then the rear side has a polymeric backsheet, as you can see over here, which is opaque. Monofacial modules are usually made of glass backsheet, so this opaque polymeric film, but newer monofacial modules can also be made with glass construction. So glass on the front, glass on the rear side. Still, they are opaque on the rear side because the encapsulant itself then has a coloring, so it's white colored, and in this way, light cannot pass through, at least in an efficient way, from the rear side. Bifacial modules mean that the module can absorb light from the front side and also the rear side. The front side is clear, it comes from a direct illumination from the sun. The rear side absorbs light by absorbing diffuse light from the ground or other panels or any other object that is located next to the panel. Bifacial modules are glass at this point. In the past, there were some glass backsheet modules. Maybe they still exist, a few, but I would say the PV industry has transitioned to glass bifacial modules. Now, talking a bit more about bifacial modules, is it a concept that makes sense mostly in utility scale projects? Of course, in utility scale projects, they are used a lot, but in this case, I would like to discuss also and show what you can expect when using bifacial modules to different project types. So, for example, when there is a tilted roof, that bifacial module is just installed on top of the roof, and then, for example, there is a module gap of 6.5 millimeters. This is the least distance between modules that you should allow, at least for our modules. The bifacial gain that it should be expected in an annual basis, average bifacial gain on an annual basis, just 3%. So not great. And this has to do, of course, that the conditions are not ideal for rear side absorption of the light. So as you can see, it's very shadowy. Then when we go to C&I roofs, and then the modules are installed on flat roof, then this configuration allows more light to reach the rear side of the module. So I would say it's not a bad idea. It's not the most efficient way to use bifacial modules, but still bifacial modules it could be a good option. Then these are for ground mount PV, fixed tilt, and then with tracker systems. With fixed tilt, the bifacial gain is lower than with tracker systems, and with tracker systems, of course, it's clear that it's the way that we can get more of the bifacial gain and the bifacial design. Now, one last thing on this section, just because it's also relevant for the South African market, and because there are some areas that, for example, they are more prone to hail. The construction of the module plays a role on the resistance of the module against hail. So, just to start a bit, to give the general information, hail resistance is tested in the standard IEC 61215, which is a standard IEC that all solar panels should have. And the minimal hail diameter that is tested there and needs to be passed is 25 millimeters. So all solar panels are in principle passing 25 millimeters just because they have this IEC. Now, Of course, this is the minimum, and then we can test much more. So in this standard, there are more haleable diameters included. So it's 25, 35, and 45. And actually, we have done testing, and actually we qualify our modules for larger hale-ball diameters. Glass modules should have no problems with a 35 millimeter hale-ball diameter. But the glass backsheet modules are more durable against hail, and they can pass the 45 millimeter test. This has to do with the thickness of the front glass. So with glass modules, the front glass is 2 millimeters, while for glass backsheet modules, the front glass is 3.2 millimeters, and this enables the better hail resistance. So 45 millimeters corresponds, let's say, to a golf ball. Actually, there are exact specs for the golf ball, and it's something like 43 millimeters, but this was the closest shaped object, ball-shaped object that I could think of in that diameter. And then for 35 millimeters, let's say it's a size of a nut. So if you install modules on an area which is prone to hail, we would recommend the glass backsheet module just because they are more durable. In areas that hail is not so a big problem, then a glass module 2+2 or even 1.6 plus 1.6 millimeters should be okay. Good. Now let's move to the second section. So how to handle modules, and handling, of course, it starts with storage. So how we store, let's say, a pallet with PV modules and PV modules themselves. Of course, it should be stored in a dry and ventilated environment whenever it's possible. And then pallets should be stored over hard and even ground. For pallets that have modules that are horizontally packed, so they look like this, actually stacking two pallets on top of each other is permitted. However, there are pallets that the panels are vertically packed, so they are taller. In that case, stacking should be avoided, or not should be avoided. It's not allowed. Of course, whenever there is a pallet, it's of course forbidden to stand or on top of the pallets or loose modules. And now, since we gave the basic guideline, let's see some real life examples of also what we have seen in the field. On the left side, of course, you can see a few examples that, for example, this one is definitely not in a even level, and this is definitely not in a dry environment. On the other hand, these two pictures give show the right way how to place pallets, for example, on a project site. When we need to unload the pallets, and then, for example, if a forklift is needed, the forklift should have cushions, as you can see here, just to protect the pallet. And of course, while transporting the pallets, the forklift speed must be limited to 10 kilometers per hour. So going very slow, just to avoid accidents or vibrations, actually, that they can create microcracks. Microcracks is something that we will also discuss later. In case, for example, there is a crane that to be used for unloading pallets, it is recommended that the upper and lower lifting points are fixed in order to have a firm grab of the pallet, and then we are able to lift the pallet smoothly. Now, in order to unpack the pallets, the following conditions should be met. The modules should be packed vertically on the long side in the table in the box, and pallets should be placed on a flat area before unpacking. This is just to avoid any tipping of the pallet and the modules and so on. When unpacking the panels, it's good if two workers carry the modules out of the box, and they always use both hands when handling the modules. Of course, for unpacking instructions, we have a detailed guide which is available in our site, and it should be read. Of course, going forward also with more real-life examples, this is also what we have seen. This is definitely wrong, and also this is definitely wrong. The modules should always have the correct orientation, and in any case, they should never be tilted in this way. Now, moving forward to installation best practices. The information is contained in our installation manual, which is available on our CSI website. And definitely what we will discuss in this in the following section does not replace the installation manual itself. So in the manual, you will find information of how to store modules, how to handle, how to install, details about mounting methods and mounting loads, and what kind of clamps you can use and so on. Information about module wiring, grounding, maintenance, and cleaning. And then we have also regarding transportation, unpacking, and so on. We have also our logistic manual, which is available also from us. Starting a bit with generic.
Vasilios, can I just
Yes,
interrupt you there?
of course,
just
Michael.
If you can go back to the previous slide. We've had a case in the last couple of weeks where the client ended up using an outdated installation manual that didn't follow wasn't pertinent to the right panels that they had installed, which contributed to modules being installed incorrectly. So just make sure whatever installation manual that you do use, that you're using the right installation manual. There are a couple of older versions that are in circulation on the web that we are trying to pull down, but the latest one is available off Canadian Solar's official website.
Good point. Thank you, Michael. I also see some activity in the chat. In case there is a question, Michael, please feel free to interrupt and so on, because.
Sure, will do.
Thank you. So generic installation guidelines, just with the basics, of course, suitable protection is always needed. This includes clothes, gloves. Of course, any jewelry should not be used like rings or anything else, or bracelets. Before commissioning the modules, it's good that the front of the module is covered, and the module should not be installed or handled when they are wet or when there are periods of high wind. In case you see some broken modules, do not use or install, and please do not attempt to repair any part of the module if you see something. For example, the junction box cover should be closed at all times, and it should not be opened. Moreover, do not disassemble a module or remove any module part. Do not concentrate sunlight on the module, and do not connect or disconnect modules when current from the modules or an external source is present. Of course, it goes without saying, solar panels can be deadly, so they can create currents, and then there is a high risk of electrical shock. So follow always the local electrical codes, use the right tools, always protect the wiring from human or animal access, and think about long-term unattended operation conditions. And of course, protect electrical equipment. All this information and precautions we have included in our installation manual, so feel free to read it carefully for more details. Now, since we are talking about electric shock and so on, grounding is recommended for CSI modules. And the way to how to perform grounding is described in detail in our installation manual. So also it's shown here. So this is the frame of the module, and actually what you will need for the grounding is an M5 SS cap bolt, an M5 flat washer, M5 cap washer, and M5 nut. And in order to do the grounding, the copper cable is placed between the flat washer and the cap washer. And then the cap washer with the game side up is placed on the frame. Once we have this configuration, then we use the toothed nut in order to tighten the bolt on the frame. Now, CSI regarding mounting and inverters and regarding system we always work in ensuring the highest applicability. So we have compatibility letters, okay, for tracking systems. For mounting methods, it's a bit more generic, but we do also for inverters. And with mounting methods, we enable bolting, long side clamping, and short side clamping for residential systems. These enable different module designs and mounting methods. And this is just a picture that one of my colleagues got. This is definitely not a solar system to be used for different reasons. One could observe that, for example, the mounting structure is missing, although this is not the only problem. And although in this picture, a mounting structure is visible still, the system seems wrong. So when building a system, a PV system, we should always keep in mind safety, mechanical stability, and electrical safety, and so on. So of course, we need to use an approved mounting system. And then when we place the modules, we need to leave at least 6.5 millimeters between the modules. Then between the module and the roof, there should be a sufficient clearance of 10 centimeters. And this will allow the module to breathe, let's say to cool down, and ensure an efficient performance over time. Regarding clamping, you should take care of the following. So the module frame should not be bended, and the front glass should not touch or should be shadowed. Also, don't damage the surface of the frame, and ensure that the clamps overlap with the module frame by at least 5 millimeters. Also, ensure that the clamps overlaps length is at least 40 millimeters, as can be seen in the picture. The clamp material should be anodized aluminum alloy, and floating type clamps are not authorized. Clamping is enabled with different mounting methods. So these include long side clamping with the rails being perpendicular to the long side, or long side clamping with rails perpendicular parallel to the long side. And then the same also with short side clamping, so rail parallel to the short side, or rail perpendicular to the short side. And then we have also different ones. So the 6-point clamping in order to achieve higher mechanical loads. And also we have in our tables, in our installation manuals, also mounting methods that are a bit not asymmetric or not standard. So rails that run over the one side of the module, and then the second one is just on the rear side of the module. Also, we have also point clamping, and also point clamping with one rail on the side. And then, of course, the mounting method, and then the range where the clamp is fixed, it will define also the durability of the module regarding mechanical loads. So here in this table is just an example of, taken from our installation manual. You can see 3 different module types, and then depending on the range, A range is just the distance between the clamp and the edge of the module. Depending on the range, you can see that the mechanical loads that the module and the mountings and the system now can withstand differ. So, for example, the more we are closer to the corners, we go to lower mechanical loads, while when we place the clamps more or less more to the center of the module, then we can reach higher mechanical loads. Apart from the range itself, so the location of the clamps, also the clamp type plays a role. This means how thick is the clamp. So let's say usual clamp width is something like 40 millimeters, but if, for example, 60 millimeters or 80 millimeter clamps are used, then this will provide a much higher strength. Moving on to bolting. Also, in this case, the module must be fastened with at least 4 points on the 2 opposite sides. It is important in this case to take care of the torques that are allowed. So, for example, with M6 bolts, the torque is in the range between 4 and 6 Nm, while for M8 bolts, the torque can be between 10 and 17. Of course, details about torques and so on can be found in the installation manual. One important thing to point out, you should never drill holes to the frame of the module. This is forbidden because it can alter the mechanical stability of the module itself. And of course, if non-manufacturer holes are added, this will immediately mean that the warranty is voided. Good. This is a quick test. I will just read the question and I will give 10 seconds. I mean, you can think of the answer alone. If you need to use a mounting method not described in the installation manual, what is the action that you should take? If there is no mounting method described in the installation manual, then there is no alternative and we can't use the mounting method. Option B, mount it anyway. There is no risk or failure. Or option C, ask the technical sales team for approval. And the answer is C. So if a mounting method is not included in installation manual, then this does not automatically mean that it's not allowed. Of course, an installation manual cannot cover all cases and all different variations of a system. Of course, in Canadian Solar, we put a lot of effort to include a lot of different mounting methods and so on. But still, it can be that a few variations can be missing. So do not think that this is not allowed. Just get in contact with us, and then we'll provide clarification how to move further. Now, during installation, of course, the module should be treated gently. In any cases, the installer should never step on the modules because this can create micro cracks. Of course, micro cracks can happen not only with forces happening from downwards, but also upwards, so like heating from in the rear side of the module, either by head or, for example, transporting modules with the head and so on, or finding some extra point to carry the module with the head is totally forbidden. And the reason is that the wafers that we use in the modules are they break, so they are not they are brittle. Of course, throughout the years and with specific module design, we have found ways to reduce this effect, but microcracks will always happen. And the best way to not have microcracks is to not create them. So please always take care of the solar panels and treat them gently so that microcracks cannot occur. And yeah, these are two examples of a failure that we noticed. I don't know if you are thinking what this could be. In an on-site training, we would have a discussion about what this could be. I could give you another hint. This is the rear side of the module, and from this picture, you can understand that there was a fire. So actually, this failure happened from a hotspot, and the hotspot can be created from the microcracks. So that's how far this failure mode can go. And how far it can go? This is a building in the UK where a PV system which was full of hotspots, so just caught fire. And the problem with fires in PV systems is that actually you cannot put them out. You cannot just throw water to them. You just let the fire burn until the end. And this means that for that building, this was the final example. So the roof was totally burned, and also the offices or apartments below them, below the roof, were totally burned. So be always careful with microcracks. As I said, modern module design have found measures to counteract the hotspot creation, but still we should be very careful. In the end, it's not only a safety topic, but it's also a system performance topic. It can be that microcracks can affect the system performance. How to identify hotspots? Usually you cannot see them. I mean, if you see them, it's already too late. Probably you will see some white spots in the. Of course, a hotspot will not always lead to a fire. It can lead to delamination, to small hotspots, to discoloration. But in order to really identify hotspots in a system, even in an early phase, usually you need IR, so infrared imaging, and this is how it looks. How a hotspot looks. So locally, you will see that the spot has a much higher temperature than, let's say, for example, the cells around the cell that is defect. Apart from microcracks, hotspots can happen also with shading. In general, shading should be avoided. As I said, apart from hotspot and microcracks, it has to do also with the performance of the system. So when light cannot shine on the front surface of the module, then energy cannot be generated. So always take care that shading, and especially permanent shading, is avoided. In order to minimize the effect of shading, modules have diodes, and which provide an alternative path for current around the shaded cells, let's say. And these bypass diodes are located in the junction box. And modern PV modules, they have 3 junction boxes with 1 bypass diode in each junction box. And then the module with half-cut design, as we discussed, they are separated in 2 different panes. The upper pane has 3 strings connecting the cells. The first one starts from here. It goes down here and it's connected to this junction box. Then the current goes here. The second string is over here, and then the third string is over here. And the same thing happens on the lower part. Now, one string is shaded. In the older modules, when we didn't have half-cut design, we actually had 3 strings from top to bottom, and then a shade at this string actually it would just remove 1/3 of power. Now the upper pane can work without problems, and then we actually lose only the 1/6, let's say, of the cell. So actually one string out of the 6. So till now we discussed about hotspots being created by microcracks, by shading, permanent shading, and permanent shading does not occur only with chimneys or antennas or a big tree located in front of the PV system, but it can be created also with other objects. And here the resolution is not perfect, but this is a nice story also from a colleague of mine who saw this installation. Actually, what you see here as white is bird droppings. So this is an installation in the port of Dundee in Scotland. And the story behind is interesting. Michael, would you like to?
Yeah.
You told me the story, so I think
it
makes sense that.
So basically, this port in Scotland, there's got obviously seagulls, and Mr. Seagull, to impress Mrs. Seagull, picks up rocks and big shells and drops it into the ocean to make a big splash, and that impresses Mrs. Seagull. Problem with these solar panels is that it kind of looks like it could be the ocean to a little seagull. So not only were seagulls dropping these rocks as big as that they could carry, they were also having a fun time excreting on it, which we'll get into the cleaning part later. But obviously the location of where you install these solar panels also makes a bit of a difference due to wildlife issues or concerns.
Thank you, Michael. And yeah, so wildlife can be an issue when it comes with getting the panels dirty. Of course, the most standard reason is the soil, so dust and so on. And this is, let's say, the #1 reason for maintenance regarding solar panels. Usually, regular maintenance.
Sorry, can I just go back? Can we go back to that slide quickly? Just to add, if someone writes, like, let's say soil or wash me, like on a car, you don't know what dust, what materials are in that, and you could end up scratching the solar panel, and also further adding to a micro crack issue. So, I mean, I know it's like a dumb thing to say, but let's not write soil or wash me before the panels get washed.
Good point. Good point. Thanks, Michael. In general, regular maintenance is recommended to keep modules clear of dirt. Either this has to do with bird droppings, seeds, pollen. It can be leaves. It can be lichen. It can be dust, soiling, or snow. Usually, a sufficient tilt, which we quantify at least, let's say, 15 degrees, is sufficient in order to self-wash the modules with rainfall. Of course, this is location dependent, and there are areas that, for example, rain is more rare, and some cleaning is needed every now and then. When cleaning is needed, so do not clean or spray water at the junction box. And then where there is a noticeable buildup of soiling on the module surface, wash the PV area with water, and then use a gentle cleaning implement like a sponge during the cool part of the day. And in case there is dirt, please never scrub or rub it away when it's dry, as this can cause micro scratches on the surface. So also what Michael mentioned in the previous example. Regarding some precautions before and during cleaning, cleaning activities create risk for potential electrical shock hazard. So whenever cleaning is performed, please make sure that the system is off, and then all active components are disconnected. Also, in case you notice some modules that are broken, there are some cracks or there are some loose connections, please take care of them and then make sure that, for example, they are not on. Wear always suitable protection, so clothes, insulated gloves, and so on. And of course, do not immerse the module in water, partially or totally, or in any other cleaning solution. Good. Now the next section is about reading a PV module dataset. The PV module dataset, it contains a lot of information, and we will go through them right now. Usually it's consisted of the first page, which is something like it has a lot of marketing information and, for example, some selling points. In this case, the dataset is about our bifacial module for utility scale modules. It's utility scale projects, but this configuration is more or less standard for any type of modules. So we can split the dataset in different sections. So in this case, we have 10 different ones, and it starts with the module type, then some product highlights, the warranty, and the certifications that we have in the first page. And then the second page is the more technical one. There you can find technical drawings, the IV curve, electrical parameters, mechanical information, temperature characteristics, and then disclaimers and version. So for the next few slides, we will go one by one. And then we will discuss any topics that concern each section. So starting with section 1, the module type. Of course, each company has a different module type. In this case, we list a table with the module types for our portfolio. So in this case, we have the PERC modules, which you can distinguish by the M. So MS means monofacial, MB means PERC bifacial. And then 6W, the number 6, denotes the wafer size. So it's 182. So the module length is always 1134 for the 6 modules, and the 7 modules is the 210, which corresponds to the 1.3 meters width. The W's and the L's refers to different sizes, and then W is the 72 cell module, L is the 60 module based on the 210, and N is the 66 cell modules based on the 210. This is a bit details. What you need to take care here is that the power scales always with the power, and of course, the bigger the module, the higher the weight. This is the table for the PERCs. For example, our 550 module is the 6WMS, and then when going to the N-type TOPCon modules, and then we have the 6WT, which is the TOPCon version of the 6W. Now from 550s, we are 560s, we are in the range of 590s. In this case, 6.1 refers to the rectangular 182 cells that we discussed in the beginning. So the 6 is the 182, with the 1134 and the older lengths. The 6.1 is the new series with the rectangular wafers, which still have the 1134 module width, but they are slightly longer. And then the 210s are the big modules, which they didn't change, that they go to the utility scale sector. Now, the second section is about product highlights. There is not so much to explain here. Usually with modules here, we state the module power, the highest module power and the highest efficiency. Other characteristics like what is the bifaciality of the module, some things that are specific to our manufacturing and how we, for example, we enable anti-PID performance and anti-LEDID, which are degradation mechanisms which we have stabilized in our modules with our manufacturing and processing. The temperature coefficient is also highlighted because it's a key selling point for TOPCon, and also all this always gives a higher LCOE and low system cost. Now, moving to the third section is about the warranties, and there are two different warranties for modules. First one is the product warranty, which is usually 10 to 12 years, as we will see also in the next slide. The product warranty includes any defects for components such as the frame, the glass, the cables, connectors, and junction box. This is what is included in product warranty. Nevertheless, the performance of the module itself has a different warranty, which is actually longer. And the linear performance warranty actually means that we give a degradation rate pattern. So for TOPCon, we guarantee that the module will not lose more than 1% of its nominal power. And then for each year, the degradation rate will not be more than 0.4%. We will see this in detail in the next table. The linear performance means that in any year throughout the performance warranty, the customer can take the module, measure it, and then if the power is not in the range that we give, then they can file a claim. Of course, the measuring a module is not straightforward. This should happen only to accredited test labs. A claim for underperforming PV modules can happen anytime during the specified period of time, as we said. And then power warranties depend on the module type, either glass or glass backsheet, or the PV technology. So there are different power warranties. And this is a small overview of what is standard for Canadian solar modules. For PERC, the power warranty was different. So it was 25 years for monofacial modules and 30 years for bifacial, which were glass. And the product warranty was 12 years. The degradation was also a bit different just because of the glass construction. 0.55 for the monofacial and 0.45 for the bifacial. However, for TOPCon now we don't have any distinction between monofacial and bifacial modules, and all modules now they come with a linear power warranty of 30 years and the product warranty of 12 years. In the first year, we ensure that degradation will be less than 1%, and then after the year 1 until year 30, the annual degradation will not be more than 0.4%. For heterojunction, we offer a higher product warranty, so 15 years, and the annual degradation is actually lower. So this has to do with the technology itself. Now, what are the different cases if there is a problem with a warranty? We can either repair, replace, refund, or replenish or refund of the warranty power deficiency. So this is what is covered for our warranties. Now moving to section 4 and the certificates. Here usually there are different certificates that either have to do with the company itself, the factories themselves. So for example, there are ISO certificates for the quality management system, standards for environmental and management system, the ISO 14001, international standards for occupational health and safety, and also IEC for photovoltaic module manufacturing quality system. These modules do not have to do exclusively for the module itself, but more with the factories and our manufacturing. The product certificates are listed in a different section, and here you can see, for example, the IECs, which are standards from the International Electrotechnical Committee, and they're recognized in EU and worldwide. But there are also other certificates that are not relevant for our region, EMEA. So, for example, CSA is for North America. C is a must for Europe for safety. MCS is relevant for UK, and UKCA is relevant for UK. Takeaway is the recycling partner that we have for our modules. And then just looking at a bit in more detail about the certificates and the numbers. 61215 has to do with reliability, and 61730 has to do with module performance. These are the standard ones. The UL are relevant for US, but the IC the versions are relevant for EMEA. Anyway, these standards are harmonized. 61701, it has to do with resistance against salt mist. 62716 has to do with ammonia. 60068 with sandblast, and then there can be also certificates that have to do with fiberglass, for example, UNI, that is relevant for Italy. Now moving to the second page, the first section has to do with the mechanical drawing. In this section, you will find exact information about the dimensions of the module, the length, the width, the position of the holes, also the cross section of the frame, and also what is the shape of the mounting holes. Next section has to do with the IV curves. Just taking a look, talking a bit about the basics. IV curve, it shows how the cell operates at different voltages and currents, and then we have 5, let's say, main characteristics, parameters that define let's say, the performance of the solar cell. The first one has to do with the short circuit current, which is defined as the maximum current that we can take out of the cell at STC. So STC means standard testing conditions. So these are the conditions that solar cells are measured, and IS is the current that we get when voltage is 0. And when current is actually 0, we get the highest voltage, which is called VOC. And somewhere in between, this is where the solar cell operates. And then the maximum power is, we get it at the maximum power point, where we defined the PM, the maximum power. And at this point, we have the voltage of the maximum power point, which is the VMPP, and the current IMPP. how square is this curve is actually defined by the fill factor, which is defined as it is, and in under the regular conditions, usually you don't need it. Now, talking a bit about power conversion efficiency and how it is defined, it is actually how much power we get out depending on how much power we put in. So as I said, usually we do a power measurement at standard testing conditions, which have an illumination intensity of 1000 watts per square meter. This is the power that we put in. And then depending on the power that we take out at the maximum power point, this is the definition of the power conversion efficiency. Of course, there are different also other ways to calculate it. For example, the VOC, ISC, and the fill factor. But in general terms, the power conversion efficiency actually it means how much power we get per area. And then this is what means module power per module area. Now these are the IV curves that we have in the data sheet. We have two. We have one where we vary the light intensity, and this is needed just to describe how the module behaves when at low light conditions. For example, early in the morning or early in the evening or in a cloudy day. And the different curves show different illumination intensities from 1000 watts per square meter down to 200 watts per square meter. In general, the lower the light intensity, the lower the current. The voltage stays more or less the same. Also, that one decreases, but what you can think is that the voltage decreases only slightly. Now, when we look at the temperature, these curves are all measured at 1000 watts per square meter, and then we measure the module at different temperatures in order to give a feeling of how the module operates at different temperatures. So we test at 4 different temperatures from 5 to 65 degrees. And the effect that you can see is that with higher temperature, actually the voltage gets lower and the current gets higher. In all, the power gets lower because actually power is voltage times current. So in the end, just combining these two effects with higher temperatures, also the power gets lower. The next section is about the electrical data. So actually, in the different power classes that we have for the module, what is of course, the nominal power? What is the voltage, the current, the maximum power point, the VOC, and the ISC? Apart from that, we have also other information like the maximum resistive voltage, which means in a string of modules, how many modules we should connect in series. When we connect in series, we actually add up the module voltages. The maximum system voltage for CSI modules is typically 1500 volts. When we size the string, we should always take care of the temperature, the ambient temperatures the low ambient temperatures that are met in that location. And with that, we actually fill our string length. We have an example also later in the slides. There is information also about the fire performance. So it's usually based on the IC 61730, which is based on the UL 790. So it's usually a C, class C. The application classification, which is usually A, which means that it's accessible to the public and has a voltage above 50 volts or power above 200 volts. And it meets safety class 2 according to the 61730. There is also information about the maximum series fuse rating when a module string is in the short circuit current. Then the current from other strings of the same sub array may flow in the string, and this is why the current of the string should never exceed the max series fuse rating. For bifacial modules, there is also information about the bifaciality, which is actually defined as the ratio between the power of the rear side versus the power of the front side. Looking in more detail about the electrical parameters, there are two different sets, STC and NMOT. As discussed, STC stands for standard testing conditions, and NMOT stands for nominal module operating temperature. And here in the table, you can see how these test conditions are defined. So STC stands for 1000 watts per square meter irradiance at 25 degrees ambient temperature, no speed and no tilted angle, so direct illumination. NMOT has a slightly different set and actually tries to represent more realistic operating temperatures. So the irradiance is slightly lower, so 800 watts per square meter, ambient temperature of 20 degrees, wind speed of 1 meter per second, and a tilted angle of 35 degrees. Now, one thing that I would like to point out about the fire performance and fire classes, as I said, the class of the module is class C, and this is tested based on the IC 61730, which actually adopts the tests that are based on the UL 790, which is a US fire standard. In there are two tests where the module in one case is exposed to a fire with a flame of 760 degrees, and then it burns for a time of 10 minutes. If over these 10 minutes, the spread distance is short enough, then it can be classified as A or B. And if, for example, it burns over the maximum distance, then it is classified as class C. In this test, mainstream modules like Canadian solar modules pass class A, so actually they have the best performance. However, in the second test, which is the burning brand, actually it means that there are small pieces of wood placed at different positions on the modules, and then they burn for a long time. At this time, there should not be any dripping from the module. However, since these burning brands are placed close to the center of the module, where the junction boxes are located with a half-cut design, then these modules cannot pass higher than class C. And then the overall fire class is actually defined by the class of the lower class of the two tests. So in the end, all mainstream modules are class C, and this is happening just because the burning brand test cannot be passed with a higher fire class. Next section is about the mechanical data. Here you can find information about the cell type, the arrangement of the cells, the dimension of the modules, the weight, the type of the front glass and the back glass, and also the thickness. So in this case, it's 2 millimeters on the front side and 2 millimeters on the rear side of heat strengthened glass. The type of the frame, the type of the junction box, the cable type, the cable length, connectors, and then some logistic information, for example, how many pieces per pallet and how many pieces per container. In this case, in this section, I would like to discuss about the cables and the connectors, just to focus there. Here is a table with our portfolio. The order goes by cell arrangement. So we start with 54 cells, 60 cells, 66, and 72. As the modules, as the number gets higher, also the module size gets higher, which means that the weight goes higher. 6RT is a glass packaging module, so the front glass is 3.2, and then we have different versions of modules. For example, glass, in this case, 5040D is 1.6 plus 0.6. This is just an overview of which module type has what weight and what front glass and back glass thickness. Now the cable length depends on the module type. So the 6 series and 6.1, which is the 1134, so the module with the narrower module width, come with a 300 millimeter long cable for the plus connector and 200 millimeter cable for the minus connector, while the bigger modules come with 360 and 200 respectively.
Just to add to that, in South Africa, we, as Canadian Solar, bring in the 1400 millimeter length cable, just to add the versatility of for the installation. But if you do need the shorter length cable, we would obviously order it in specifically for a client, in container quantities, obviously.
Exactly. So as Michael explained, so these are the portrait cable lengths, and of course we have also longer cables for example, landscape installation. For connectors, we enable T6, which is a Telian, which is manufactured by Telian, which is a subsidiary company from Canadian Solar, so our own connector. And then we also enable MC4 and also Evo2, which is an MC4 variant for 1500 volts.
Sorry, okay, you're talking about the connectors. Sorry, Vasilios, I jumped ahead there. My apologies.
No problems, no problems. So C-side modules are available with different connectors, T6 or MC4 or MC4 Evo2. As I said, the T6 are manufactured by Telian, which is 100% owned by CSI. And CSI can also supply T6 connectors, separate items, or T6 toolkits, which includes crimping tools, disconnect tools, and so on. It should be noted that all Telian connectors are compatible to each other because we have different variations also with different for different cable cross section from 4 to 6 millimeters to 10 millimeters square. Nevertheless, here I would like to point out that connectors of different manufacturers should never be connected to each other. This is a safety guideline, and of course, if you try, they will mate to each other, but this should definitely be avoided. And the reason is that the specs that are usually used and the recipes that are usually used for alloys can differ from different manufacturers. And then if at the connection point between two different connectors, there is a difference in resistance, then this can become a point where high temperature will occur, and then maybe we will have a case of fire. Now, I would like to discuss in the case that Canadian Solar modules come with T6 connectors, and then there is an inverter, for example, that have MC4 inputs. This can be solved with cables that on one side have a T6 connector, and on the other side, they have an MC4 connector. This, for example, can be a home run cable, or if you need a shorter cable, we can also provide jumper cables that go from T6 to MC4. In any case, replacing the connectors on the modules without prior communication with us should be avoided, and this will void also the warranty. In general, during during it should be taken care that connectors are not waterproof, and whenever modules are installed, then the connectors should be connected to each other as soon as possible. If for any reason the modules will stay, let's say, an unprotected environment for some time, then protective countermeasures should be taken, for example, using connector end caps in order to block moisture and dust from penetrating into the connector. Finally, the ninth section has to do with temperature characteristics. So in this case, you can read the temperature coefficients for the power, the voltage, the VOC, and the IEC, and these that differ between different PV technologies. And actually, for performance at high operating temperatures, it's good that the temperature coefficient for Pmax is the lowest possible. So in this case, between PERC, TOPCon, and heterojunction, the temperature coefficient for Pmax for heterojunction is actually the one giving the best performance at higher operating temperatures. The temperature coefficients for VOC and ISC can be used in order to size system components, as we will show in the next two slides. Starting from with the VOC, we said that the VOC increases at lower temperatures, and the open circuit voltage at a specific temperature can be calculated using this formula. So this is a correction factor, which in the end you will need to multiply to the VOC measured at STC. And then this constant is the temperature coefficient for VOC. This means that if, for example, you have a project site that you know that the lowest extreme lowest temperature is minus 10 degrees, then you can use the temperature coefficient. You can plug the temperature coefficient here, then 25 minus 10, and then you can get a correction factor which will be in the range between, let's say, should be 1.14. If you don't want to do a precise calculation with this formula, we already provide a table with the different correction factors in our installation manual. So you are free to use also values directly from our table. The VOC at a lower temperature gives the highest VOC that we should expect from the module, and this is important when we size strings. Also for in the inverters, it is important also to have a feeling of what is the maximum current that we can have from our modules. And in order to do so, you can use this formula again by using the temperature coefficient for the ISC. And then here we can plug the temperature, the highest temperature that we expect in the project site. Now, when we need to size fuse ratings for monofacial modules, the method is to multiply the module ISC under STC by 1.56, and then the string fuse ratings should be lower than the maximum string fuse rating listed in the datasheet. And if in case you use bifacial modules, the methodology is the same. So you multiply the ISC by 1.56 and then again by 1.2. This is just to add a little bit more buffer regarding the bifacial gain. Good. Since we are discussing about temperatures and so on, it is worth mentioning that different installation methods can lead to different operating temperatures. So the operating temperature is affected by how we install our modules and what kind of project we have. These two maps actually show how the module temperature changes over different locations with when we switch from an open rack installation to a closed roof. Closed roof means that the module is very close to the roof. So this should be minimum 10 centimeters. And this leads, for example, in South Africa, it leads to a temperature that it goes up to 80 degrees. Now, the standard testing tests the modules for temperatures up to 70 degrees, but with at CSI, we built modules which can qualify and pass the IEC 63126 level 1, which is actually a standard that tests the modules at the operating temperatures up to 80 degrees. So in the end, you can expect that the CSI modules are more heat resistant and more suitable when, for example, we have such challenging installations like this one. Good. This was my last slide for this section, and this is more or less my wrap up. At Canadian Solar, we manufacture modules for different applications, and this means residential, commercial, utility, small, large, off-grid. We always look at the specifics of its project type, and we optimize our modules for these applications. This is a quick view of our product portfolio. Residential, C&I, and utility. Actually, these are just guidelines based on the size. So as you are starting from the left, going to the right, the module size increases. So 6RT, 6.154TD are small modules in the 450 range. Then we have a C&I module 60 dB, which is more in the 500 watt range. And then we go to larger modules for large C&I rooftops and ground mount PV like 6W and 72TD. These are the monofacials, and then we have also the bifacial versions, 6WTB and 72TB, and we are soon launching 6.2 66dB. All this information, you can find them also via IBC Solar. A few words about our TopCon series, just to give an idea why it makes sense to use TopCon. It comes with high power and higher efficiency. So right now with our module portfolio, we can go up to 715 watts and module efficiency up to 23.2, which is a significant upgrade compared to TopCon to PERC. Then TopCon is much more efficient compared to PERC when we have high operating temperatures. So the temperature coefficient is much lower, which means that the power loss at a higher temperature is much less. The next important point is that we have a much lower degradation and improved warranty. So now the lifetime, the warranty of the modules goes up to 30 years, and we also guarantee much better degradation. So over the module warranty, we guarantee 87.4% of the nominal power. Of course, this means that there's a high rate of return with increased energy yields and lower BOS costs, which reduce the LCOE. And of course, all this is done with the highest quality production of Canadian Solar, which ensures long-term reliability and performance. As a closing note, I would like to go back to my introduction and say that right now there are challenges in order to make solar available more and more. And the challenge for professionals is to choose the right products and install them in a long and in a safe way that ensures long operation. Our challenge as technology suppliers is to give you the best products and assist you in the realization of the PV systems for your customers. It is natural that PV installers doing a good job using good components will grow from small business to big installers, and Canadian Solar will follow you all the way to grow with you. In the end, know-how is the key to success. That was it from my side. I would like to thank you for your attention. And Michael, I don't know if you want to make any remarks.
So I know we've got a question in the section. We will touch on that now. I just want to quickly add a little side piece on grey stock and counterfeit stock, just to kind of explain what Canadian Solar is doing about it. So IBC is a legitimate distributor of Canadian Solar, so you never have to stress about whether your stock is fake or a grey imported item. Why we speak about grey imported items is that Canadian Solar does not honor the warranty of grey imported Canadian Solar stock. So while it may be authentic Canadian Solar products, we know that it might not be designed for our market, and it has been brought in illicitly. We don't bring in B grade, C grade, D grade panels. We only bring in A grade panels. There's no the gray stock that comes in. We cannot guarantee what stock that is. More often than not, it tends to be B grade, and that obviously offers a different warranty. B grade panels tend to only be available in China itself. We've also found there's now the most recent incident of grey stock is that there's 550 watt panels, Arceus 6WMS modules that are coming into the country with 36 modules on a pallet. Now, our 550s only come with 35. So just double check when you're buying panels, if it's not from IBC, for example, you need to just double check the serial numbers. We are busy launching a serial number checker that'll be launched in the next week or two. And in the interim, you can email the serial numbers to Canadian Solar and they will check it for you. Canadian Solar, South Africa. It is very important that you obviously have stock that has a warranty behind it, obviously, and to make sure that you are not getting a blended stock. So blended stock is when they sell you 15 panels of real Canadian Solar, or not grey stock. Then they sell you a blend of grey import and even counterfeit stock. With regards to counterfeit stock, we as Canadian Solar are leading the charge in terms of the manufacturer, in terms of the group of manufacturers. Where we are working with SAPS's commercial crimes unit, as well as SARS, in doing raids at various points. It's a continuous battle, but we find that our brand is at the highest risk of being counterfeited due to the name Canadian. Just when you buy panels, make sure that the serial number that you have matches the front and the back, firstly, and then secondly, at the bottom of the panel, depending on which way you look at it, the serial number will be behind the glass, not in front of the glass. And if you see that the panel, that the spec, this little spec sheet label, not a spec sheet, but like a label of some sort at the back of the panel has been tampered with, immediately the warranty is null and void, because what happens is people tear it off and then they stick you think you're buying a 550 watt and you're actually buying a 460 watt, for example. So as I said, IBC's they're a trusted distributor. You don't have any issues with when you buy from IBC. But I'm just making sure that you are aware of what is in the market. I know that a lot of people tend to shop around. And currently in South Africa, you're seeing pricing that is ridiculously low. If it seems too good to be true, it probably is too good to be true. So just make sure that whatever you are buying, there is a warranty behind it, whether it is not Canadian or whether it's Canadian or JA, Genco, Longi, whatever it is. So please just make sure that you're not wasting your money or you're buying a product that doesn't have a warranty behind it. And then just to touch on ESG, if you do have any big commercial projects, then you can access our ESG portal. On our website, we've got everything from forced labor to how much water we were using in our Cape Town office, our Munich office, everything is in there. And if you need anything a little bit more intricate, you are most welcome to reach out to us through IBC, and we can provide you documentation that if it's not available on our website. That's all from my side. I just want to ask a question to Vasilius. We've got a question here. How does partly shading, temporal shading with or without optimizers impact the warranty, especially hotspots that might have been created right at the temporal shaded or partly shaded areas?
In general, optimizers and module level power electronics can help in avoiding hotspots and so on. If there is such a case, I would say that it's better to just come to us, to our after sales team, and then they will investigate it in more detail, because probably the whole topic needs to be checked more thoroughly.
Cool. And just to add on that, we've got Vasilius is sitting in Germany, but I sit in Johannesburg, and our offices are in Cape Town, where we've got a team of about 20 odd people. We have local representation here, and we have had local representation here for many years. So if there is any issues, you would be dealing with IBC and then obviously us, and we would be helping to sort out any after sale issues, whether it's on a module side or an inverter side. So and the response times have improved drastically. I know that in the past there was a bit of an issue, particularly on the inverter side. I can say, having come from a distribution background myself, that it has improved significantly, and our response rates are, I would argue, as one of the best in the industry. So just to add on that, are there any other questions that anybody might have? I don't know if you can unmute yourself and you can ask the question, or you want to put it in the chat. Maybe we'll just look. You can stare at my face and Vasilius's face for a minute or two while you type, or you can just chat, unmute yourself. Yeah, but thank you for joining us. We really appreciate your time for attending this. We are going to be doing a lot more with IBC in the future, so be on the lookout for that. And yeah, thank you, IBC, for hosting us.
Thank you guys for the training. It was a very fruitful training, and I think everybody learned a little bit of something. And yeah, if you do have questions, please feel free to then drop your email, drop your question, and then we will then get back to you. I see we're almost running out of time, so I'll just give it a bit of time. We'll just wait. If you have questions, please feel free to drop your text, to drop your question, and then Vasilia or Michael will then respond to your question. So our training, I think we can say our training is complete, but we will just wait for a few minutes to answer as many questions as possible. And if we do not get back to your questions, we will then contact you to help you or answer your questions. And yeah, once again, thank you, Michael and Vasilia, for the training. It was a good training.
Thank you very much. Thank you.